Welcome to Coach Taylor's class videos. Today we're going to look at transversals cutting through parallel lines. So a real quick brief overview about parallel lines. They are two lines that never cross. Parallel lines are identified by arrows. And they're going to be filled in and they're going to be on the lines. And I'll give you another example here. When we talk about parallel lines, if we're looking at these two right here, the way we would note it is AB and is a line. So we have to put the line symbol above AB. Then our parallel is two lines that do not cross. And then we're going to put CD, not CB. And again, CD is a line, so we must put our line symbol above it. So if we look at line AB and line CD here, we notice that they have these two arrows here. So these two arrows are what tell us that AB is parallel to CD. And so again, these arrows is what notifies us that they are parallel. So last set of notes, we looked at transversals, and we looked at transversals of non-parallel lines. And so when we have non-parallel lines, all we can talk about are the angle relationships. But everything changes when we know we have those parallel lines. So when that transversal goes from looking like that to looking like this, we know a whole lot more things about our angles and the angle relationship show. So again, this is non-parallel lines, and then this is parallel lines. And so today's video, we are only going to be talking about when those two lines are in fact parallel. Again, there's a lot more information that we know. So the information that we know is that when we have a transversal that cuts through two parallel lines, corresponding angles are congruent. So if they're in the same location on the same side of the line, we know they are congruent. If they are alternate interior, so they are inside the two parallel lines and they are on opposite sides of the transversal, we also know they are congruent. Same thing for alternate exterior. If they are outside the two parallel lines and on opposite sides of the transversal, they are congruent. Now, when we get consecutive interior, that means they're both on the same side of the transversal and they're both in between the parallel lines. We know that the angles are supplementary. And if we remember from last unit, supplementary means that the angles together equal 180 degrees. Our consecutive exterior angles are also supplementary, which means they equal 180 degrees. One last thing to keep in mind when we're talking about parallel lines and transversals is what we learned in Unit 1. And at Unit 1, we learned about vertical angles, and we know that vertical angles are always congruent, but they must be on intersecting lines and be on opposite sides for them to be congruent. The other thing that we learned was we learned about a linear pair. They must be adjacent and on the same line, which makes them supplementary. So all supplementary angles are 180 degrees and all linear pairs are automatically supplementary. So these are the things that we are using going forward to talk about parallel lines and transversals. So let's look at this first example right here. So let's look at angles 3 and angle 5. So the first thing that we have to notice about this diagram is we have to notice that this right here and this right here. So we said on the last page that two angles means that these lines are parallel. And so once we know that these lines are parallel, we know a lot more about these angles. So let's look at 3 and let's look at 5. So the other thing that we need to remember is we need to remember interior versus exterior. So we said interior is anything that's in between, in this case, the two parallel lines, and exterior is anything on the outside. So I know that these are interior And I know that they are on opposite sides of the transversal, so that means that these are alternate interior angles. And I know that alternate interior angles are congruent. So I know that angle 3 is congruent to angle 5. So now let's look at angle 1 and let's look at angle 8. So they are outside the yellow, so I know that they are exterior, and they are in the same side of my transversal, which means that they are consecutive exterior angles. And I know that consecutive interior are supplementary and equal 180 degrees. So I know that angle 1 plus angle 8 equals 180 degrees. I'm going to throw the little measure M right there as well. I'm going to try and keep this color-coded as much as I can, but I'm going to have to end up repeating colors. So 2 and 6. So I have angle 2 and I have angle 6. They're on the same side of the transversal, so that means they're either going to be consecutive or they're going to be corresponding. 2 is above one of my parallel lines, and 6 is also above the other parallel line. So that means they are in the same position, which makes them corresponding angles. And if they are corresponding angles, I know that that means that they are congruent. And so if they're congruent, angle 2 is congruent to angle 6. So now if I look at angle 1 and I look at angle 7. So we've already used 1 once, so I'm going to put a big circle around it again. So I know that they are both outside the yellow, which means they are both exterior angles. I know they are on opposite sides of the transversal, which makes them alternate. So they are alternate exterior angles, which means that they are congruent. And if I have congruent angles, that means they are equal. So the measure of angle 1 is congruent to the measure of angle 7. All right, and now I get to start repeating colors. So let's erase some of this stuff right here and let's start over. So again, I'm going to shade the interior so that helps us visualize and helps us see. Then we're going to go back to blue. So now I'm looking at angles 4 and angles 5. So I know that they are both interior because they are both in the yellow. And I know that they are on the same side of the transversal. So that makes them consecutive interior angles. And I know that if I have consecutive angles, I know they are supplementary, which means they equal 180 degrees. So the measure of angle 4 plus the measure of angle 5 equals 180 degrees. Now let's look at 3 and 7. So 3 is interior, 7 is exterior. So here's a quick tip. If I have one interior and one exterior, they are always going to be corresponding angles. Because for them to be in the same position as each other, one must be interior, the other must be exterior. Now that corresponding angles are congruent, so I know that angle 3 is congruent to the measure of angle 7. All right, now we've got 5 and 6. All right, so let's look at 5 and let's look at 6. They are both interior, but they are adjacent. So they are next to each other and they are on a straight line. So if they are next to each other, adjacent, and on a straight line, I know they are a linear pair. And I know that linear pairs are supplementary, which means they equal 180 degrees. So the measure of angle 5 plus the measure of angle 6 equals 180 degrees. And finally, let's look at angle 2, and let's look at angle 4. So angle 2 and angle 4 are on opposite sides, but they are also on a pair of intersecting lines. And if they are on opposite sides and on a pair of intersecting lines, I know that they are going to be vertical angles. And I know that vertical angles are congruent, which means the measure of angle 2 is congruent to the measure of angle 4. And so that's how parallel lines changes transversals, is because we know that these angles they follow a pattern, and in fact they are either congruent or they are supplementary. So let's talk our way through this next one. This next problem tells us that the measure of angle 1 is 65 degrees. And so we're going to compare every angle to angle 1 to figure out what their actual measurement is. So if I look at angle 1 compared to angle 2, so I know that 1 and 2 are a linear pair because they are adjacent. Well, actually, first I have to notify, all right, both of my lines are parallel. And so once I know they are both parallel, I can mark interior versus exterior, which makes my life easier. And I know that if they are a linear pair, that they add up to 1. That means they're supplementary. That means they equal 180 degrees. So if I go 180 minus 65, I get 105. So the measure of angle 2 is going to be 105 degrees. So now let's look at angle 1 and angle 3. So angle 3 is here. I know that they are across from each other. I know that they are on intersecting lines, which makes these vertical angles. I know that vertical angles are congruent. So if angle 1 is 65, that means that angle 3 is also 65 degrees. Now let's look at 1 and angle 4. So 1 and angle 4 become a linear pair, which means that they are supplementary, which means that they equal 180 degrees. I also know that angles 2 and angle 4 are vertical angles, which makes 2 and 4 congruent. So if 2 is 105 degrees, that means 4 is also 105 degrees. I also know that 105 plus 65 is 180, and since they are a linear pair, that's how that works. So now let's look at the measure of angle 5. So if we look at angle 1 and angle 5, I have 1 exterior, which is angle 1. I have 5, which is interior. They are on the same side of the transversal. They are both above a parallel line, so this makes them corresponding angles. Oh, let's spell today because that's spelled completely wrong. I know that corresponding angles are congruent. So the measure of angle 5 is the same as the measure of angle 1, which means angle 5 is 65 degrees. Now let's look at angle 6. So 1 and 6 do not have any relationship. They're not vertical angles, they're not linear pair, they're not corresponding, they're not both interior, and they're not both exterior. So I'm going to have to use another angle relationship to help me figure out what angle 6 is. And I can figure that out based on a bunch of different ways. I'm going to choose angle 4. I know that angle 4 and angle 6 are alternate interior angles. So I know they are congruent. So I know that 4 and 6 are the same. So I know that 6 is 105 degrees. I just realized I stopped putting the degree signs on the specific angles. There we go. All right, so now I'm going to look at 1 and 7. So 1's over there, 7's over here. They're both exterior, and they're on opposite sides of the transversal. So that means they are alternate exterior angles, which means they are congruent. So that means angle 7 is the same as angle 1, and so angle 7 is 65 degrees. And finally, we've got angle 8. 1 and angle 8 are both exterior. They're both on the same side of the transversal, so they are consecutive exterior angles, which means they are supplementary, which means they add up to equal 180. If angle 1 is 65, we've already done 180 minus 65. So I know that angle 8 is 105 degrees. So that's why we really like these angle relationship pairs and parallel lines, is once we know the measurement of one angle, we can find the measurement of every single other angle in the transversal. We're going to do a lot more of this going forward, but this is the basis of our parallel lines and our transversals.